In this video, we're going to learn how to verify the two given functions being inverses of each other. Namely, we're going to test the composite functions of these two functions to check whether the two functions are inverses of each other. And what I mean is that we're going to use the formula of the composite, which is plugging the g as the input of f and making sure that that is equal to the f of x being plugged into the g function, and also making sure that these two results are both equal to x. Okay, so two things that you have to do. You have to make a composite function in which the g is the inner function, input of the f, and that's equal to another composite function in which the f of x is the input of the g, that's the inner function, and that both are equal to x. That's the only way for these, the f and g, to be inverses of one another. Let's test using the example. If f of x is equal to x minus 5 and g of x is equal to x plus 5, let's test whether these two are inverses of each other. So first we're going to find f of g of x. Okay, so that means the g is going to be plugged into this input x. So that means x plus 5 will be plugged in to this parenthesis, right? So basically we're testing f of x plus 5 because that's the g value, x plus 5. All right, so that's going to be x plus x is replaced by x plus 5. So we get x plus 5 and then minus 5 copied. Notice that's equal to x. That's already promising, right? Now we have to test another one. We have to test the other way around. The f of x will be the inner function of the g. So that means you're finding the g of x minus 5. Okay, because you're putting the f into the input of g, right? So g of x minus 5, you're replacing this x with x minus 5. So x minus 5 plus 5. Beautiful, right? So that means this result means yes, right? Because these two composite functions, the g inside and then the f inside, prove that both are equal to x. Okay, so that's good. Now let's test the second example. When f of x is equal to 7x plus 1 and g of x is equal to x minus 1 over 7. Let's test what happens then. Let's find first the f of g. So we're trying to find what? We're trying to find of f of x minus 1 over 7, right? Because that's the input of the f. Okay, so we're going to replace this x with this whole big fraction, right? So it's going to be 7 times x minus 1 over 7 plus 1. Okay, what does that give us? Notice that the 7's cancel out because there's a product of 7 and whatever's inside, so the 7's cancel out. Right, so that's out, that's out. So we just get x minus 1. But not to forget plus 1. And guess what? This is equal to x. That's good. Let's test the g of f of x. Okay? Now, g of x means that we're finding the g of what? Of the entire f of x, which is 7x plus 1, right? That's the input of the g this time. So we're going to replace this x, lone x, with the 7x plus 1. 7x plus 1, and then minus 1 copied over, divided, don't forget it's a fraction, by 7. So we get 7x over 7 because that's 0 there. Now 7's cancel out, right? Because cancel out meaning 7 over 7 is 1. It does mean 0, be careful. 1x. Good. So what does that tell us? Again, these two are inverses of each other, right? These two given functions. Let's try the third example. What about if we have f of x is equal to x cubed divided by 3? And g of x is equal to third root of 3x. Let's test that. Let's first find the f of g. So we're trying to find the f of this cube root, right? Cube root of 3x. So that means we're replacing the x cube, not the x cube, the x itself with the cube root of 3x, right? So it's going to be cube root of 3x, and that's cubed, right? Divided by 3. Notice that the cube of a cube root, that means the cube root is gone, right? And there's no cubic power anymore. is just the inside that's available, right? So it's going to be 3x over 3. 3's cancel out, right? Meaning 3 divided by 3 is 1. 1x is x. Good. Now we're going to find the g of f. Okay? So g of f means we're going to find the g of this entire function. So the input is x cubed over 3. Okay? So that means we're going to put the cube root of 3 times, instead of this x, we're going to put the entire input of that fraction, x cubed over 3. Okay, what does that tell us? First of all, notice that the 3's cancel out inside that cube root. So it's just going to be cube root of x cubed. Good. Cube root of x cubed also cancels out all the 3's, right? The cube root is gone, the third power is gone, it's just x. All right, again, the third example also yields 2 inverses. Right, now the last example, let's test that one. We have f of x, 2x plus 5 over 4. And then the g of that will be minus 5 minus 2x. Okay, let's test whether these two are inverses of each other. So find f of g. That means we're finding the f of, the input is the entire g function, minus 5 minus 2x. Okay, so that's going to be what? That's going to be 2 instead of this x. We put the entire input of, which means the g, right? So minus 5 minus 2x, and then don't forget it's a fraction. There's a plus 5 in that numerator still, and divided by 4. Okay, what does that tell us? So that's negative 10 minus 4x plus 5 over 4. Okay, now notice there's no way that this is going to be equal to x because first of all, everything else must cancel out and we have to have 1x. Minus 10 plus 5 is not 0 to begin with. And even if they were 0, minus 4 over 4 is negative x, and that's not positive x. Right? So that's not equal to x. So that's already enough to not even test the second g as a function of x. Right? Because one already failed. If one of them fails, it's not equal to x. You don't even have to test the other one. Because even if the other one is equal to x, the first one fails, right? The first one is not equal to x, right? So that's a big no. These two are not inverses of each other.